Hello everyone. Let's start with today's topic, that is force and laws of motion. So it's a topic from physics from standard 9, and we will discuss it in a very simple way to understand what is force and what are the laws of motion and how they are connected and related to each other. So first of all, let's start with the simplest question, that is, what is force? So, the very simple answer and the very beginner friendly answer is force is push or pull. A very simple answer. What is force? Force is push or pull. And for example, pushing a door, that means we are applying a force. Pulling a door, there is also a force. If you are kicking a ball, there is also a force. So now the formula of the force is mass into acceleration. Now you know what is mass. So well, there is difference between weight and mass. And interestingly, it's the force that makes the difference. So we will discuss that in the higher classes, but right now this is not very relevant to us, this formula. But you should know that force is equal to mass into acceleration. Suppose if you get a numerical question in which we have got the direct values, so we can easily calculate force by multiplying the value of mass with the value of acceleration. Now the SI unit, we all know unit, and SI unit is system of international units. Like, so the unit is Newton, which is equal to kg into meter by second square, which we can write like this, second inverse square. So this is important. This Newton is important, and you can also, remember this. And this is derived from this formula only. So the SI unit of mass is kg, and we all know the SI unit of acceleration. So it is nothing but it is derived from here. Now force can make a moving, these are the properties of force. So, force can make a moving object stop. It can make a stationary object move. It can change the speed of an object or a material. It can change the direction, and it can change the shape. So these are the five properties of force. And now force, we can divide it into two parts, contact force and non-contact force. The contact is muscular force, the force that is applied by, that is, applied by our muscles. Uh, for example, if you are kicking a ball, then it is kicked by your leg. If you are rolling a roti, then it is, the force is here applied by your hand. If you are holding a bag or a heavy material, it is, being held by your hand. So in all these cases, the force is applied by the muscles. Now the second is friction. Now friction is a very, you know if you have seen a ball rolling on the ground, and after a certain period of time it stops, because the ground applies a friction force on the ball, and friction is in always the opposite direction of the motion. So we will discuss this later. Now non-contact force are the gravitational force, magnetic force, and electrostatic force. So all the object that has mass applies gravitational force. The magnetic force are the force that is applied by magnets or the material having magnetic properties. And electrostatic force, the force by the electric charges or the current carrying object. So, as the name suggests, we can write a simple one liner definitions from this. Now, if we talk about balanced force, that is two or more forces that act in the opposite direction, they cancel each other. So, what are the balanced force? So, balanced force is that, in a very simple language, we can say that if two or more forces act in the opposite direction, that means the net moment happening on that object is zero. That means there is not any change happening, because the force that is being applied are getting cancelled by each other. So the net force is zero and object doesn't move. For example, pushing a ball, and for example, if you are pushing a ball, it does not move because the force that you are applying on the ball is balanced by the same force that the ball is applying on you. So the force is balanced here. And if you talk about unbalanced force, that means force, uh, a situation where forces do not cancel each other, and because the force is not always, there can be many situations. First situation in which the forces are not cancelling each other. Second situation in which one of the forces is greater in magnitude than the other force. Now, what is magnitude? It's a very simple word that we use daily, but very few people know, the exact definition. So, magnitude is nothing but the numerical value. So, force is a quantity which has both magnitude and direction. We all know this is the basic thing that we all know. Now the magnitude is the numerical value and direction. We need to mention the direction of the force because it is a vector quantity. In your higher classes, you will study the about the physical quantities, which are of two types: scalar quantities and vector quantities. So the scalar quantities are those which has only magnitude, but the vector quantities have both magnitude and direction. Now, I have already mentioned this, and you can see, like, this is a box, and A is applying a force, and there is a force from B. And if it is not moving, that means the magnitude of the force of A is equal to the magnitude of the force of B. And in this case, A and is equal to B, and box will not move. In the case of unbalanced force case, there can be two option. If the box is moving in the direction of B, that means B has a greater force. If it is moving in the direction of A, that means A has a greater force in magnitude. So why are we talking about direction and motion? I have already cleared, because we know that force brings motion, and that motion which will be in certain direction. So there will be a direction of force. In the higher classes, you will find force is a vector quantity, which means we need to define its magnitude and direction as well. So force is the interaction. Now, do you know what is interaction? Interaction in which two or more bodies are, being involved with each other. So force is the interaction with or without contact, which means two body gets involved. Two or more bodies also get involved. So Earth up, Earth applies force on you, which is called gravitational force, or we say gravity commonly. So why don't we observe its effect? Because it is balanced by the other forces. At this moment, force is a push or pull, so it can change motion or shape, but every time, no. Sometimes force changes motion and sometimes it does not. Sometimes it's big and sometimes it's not. And that is why Newton's law came. So what is Newton's law? Newton's law Newton's law defines or explains the effect of the motion due to force and how motion is related to force. Now this is the entire point of the chapter. In in this chapter, the main motive is connecting motion with force and how they are related to each other. So at this point, we know that force generates motion, and Newton's law will define the relation between the motion produced and the force. Now let's start with the Newton's first law of motion. So the statement is a body remains at rest or in a uniform motion in straight line unless acted upon by an external unbalanced force. Now, if we talk about the statement, it says that a body remains at rest. If a body is in rest position, it is not moving, or we are taking two cases. So, first case in which the body is not moving, and second case it is moving but in a uniform motion. Now, now uniform motion. It's uniform motion is the situation or the motion in which equal distance is covered in equal interval of time. The speed is constant. So in this case, they will continue their motion, or it, like, we are considering the two cases, and the cases will continue. If it is in rest, it will be in rest. If it is in uniform motion, it will be in uniform motion, unless acted upon by an external unbalanced force. Now, it's important to mention external and second unbalanced force. So, their situation will be changed only when an external unbalanced force means, uh, like, the magnitude of one of the forces should be greater than the other one. Only in that case the disturbance will be created, and the change of the, you know being will be happen. So if it is in rest, it will be in motion. If it is in motion, then it will come to rest. This is the first law of motion, and it is also called the law of inertia. In the very simple word, I would say the first law of motion is the, you can explain it in a very easy way. It's, if a body is in rest, or it is in a uniform motion, it is going to continue, it is going to sustain its state of being until it is acted upon by an external unbalanced force. Now let's talk about inertia. So inertia is a tendency of a body to restore its state. Now you know why the body will sustain or retain its position, retain its state, because of inertia. What is inertia? Inertia is a tendency, or it is a property of a body to restore its state. If a body is in rest position or it is in a uniform motion, it is going to resist or protect itself from changing its state. Because change is difficult. This resistance to change is called inertia, in a very simple word. Now, inertia depends on mass. That means if we are comparing two bodies, the one with the larger mass will have more inertia. Very simple word. Now, the inertia, we have three parts. The first, rest, then motion, then direction. Three type of inertia. Now, let's talk about inertia of rest. The tendency of an object at rest to remain at rest. Very simple, very point to point statement, very easy one. So, for examples, now let's consider a few examples. The first, a book lying on a table stays at rest. So, if there is a book on the table, it is going to be on that table until unless you pick that book. You pick that book up. If you're not creating any disturbance there, the book is going to be there forever. This is nothing but inertia of rest. Now let's talk about the other one. It's dust comes out when a carpet is beaten. You have must seen, when we are doing dusting in our home, we beat the carpet and the dust comes out from it. It is only coming out when we are beating it. And if you are simply ignoring it, you are not even going to notice that there is a dust in your mat. Don't forget to do this at your home. And the third, a coin falls into the glass when the card is flicked, and it's a very interesting and very common example. So what you have to do, you have to pick a glass, you have to pick a card, and on that, put the card on the glass, and now put the coin on the glass. And if you flick the card, the coin be will be at its position only. It will not go with the card. It will fall into the glass, and this shows the inertia of rest. The inertia of the coin was to restore its position. It was in rest, so it will not come in motion. And this is the best example from my POV. So object resist coming into motion. This is the main point. You should keep that in your mind. Now the second is inertia of motion. The tendency of the moving object to continue moving with the same speed in a straight line is the inertia of motion. Very simple, exact opposite to the inertia of rest. The main point here is that the object resists stopping, coming to rest. So it is going to continue its motion until it is, affected by an external force. So let's consider examples that, have you noticed the passengers, when a bus suddenly stops at a signal, the passengers fall forward. Have you ever wondered why? So the reason is nothing but the inertia of motion, because initially the passengers were in motion, with the bus was moving, they were moving, and all of a sudden the bus has come to stop. So the inertia of the body of the passenger, it will force them, it will not force them, but it will, try to be in motion. That's why you suddenly feel a forward push. In the later classes you will know that is called jerk, and we will discuss that in the higher classes. But you will feel that motion, the forward push. Second example is the rolling ball keeps moving on the ground. So, this is a very interesting um, example. If you roll a ball, so after a certain period of time, it gets stopped because it is acted because of the effect of friction on that. But when the ball falls from the motion, it continue its motion. Just consider this point. Now the third example is a fan keeps rotating even after switching. Have you ever wondered, when you switch off the plug of the fan, why don't it immediately stop? Like, I mean, why does have you ever wondered why even after switching off the plug it rotates? Because the petals of the fan try to, they resist stopping and they try to continue their motion. Now let's talk about the inertia of direction, the tendency of an object to continue to be in the same direction. The passenger leans sideways when a car takes a turn. You all have experienced this, and the reason is nothing, just inertia. Stone tied to a string moves in a circular path. This is a very classic example. And water spills sideways from turning bucket. The object resists change in direction. Now we know why does a body not change its motion instantly. The reason is because change in motion needs time. And to move a body or to produce motion, the applied force must overcome inertia for some time. This is the most important line from this page is to move a body or to produce motion, the applied force must overcome inertia for some time. Now, the first law is explained by inertia, and very important point is that inertia is not force. Force is simply a push or pull. It is the interaction between object, but the inertia is a tendency of an object to be in its state. It can be, at rest or at in motion. Now let's move to the second law of motion, Newton's second law of motion. The statement is the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of force. Now this is the most important laws of motion in the world of physics. Now let's start with the word momentum, and it is a measure of the object's quantity of motion. Momentum is nothing but the quantity of motion. Mathematically, momentum is equal to mass into velocity, and it is denoted by the letter P. P is equal to m into v. And P is directly proportional to mass and velocity. If you increase momentum, mass will increase. If you increase mass, the momentum will increase. If you increase velocity, the momentum will increase. Now let's move to the most important part of the from like one of the most important part from this chapter. It's the derivation of the second law of motion, and one of the most asked questions in the school and institute. So now let's derive. From so in the world of physics, we all know the language of physics is maths. So we will use a lot of maths here. So let's consider mass is equals to m, initial velocity is equals to u, and final velocity is equals to v. Time is equal to t. Now the initial momentum is represented by pi, the final momentum with pf. So we have two situations. Now we know that momentum is equal to mass into velocity. The initial velocity is u. So initial momentum is equal to mass into u, initial velocity. Final momentum is equal to mass into v, final velocity. So change in momentum, and we all know how to find a change. Just minus it, subtract it. From final minus initial is change. So mv minus mu, taking m common, and we have m into v minus u in the bracket. So, and the rate of change of momentum is nothing, just divide the quantity by time to get the rate of change. So m into v minus u by t is nothing but the rate of change of momentum. And the second law of motion states that the rate of change of momentum is nothing but force. So force is equal to m is a m into v minus u by t. Now I want to discuss something, that here m is mass, v is final velocity, and u is initial velocity. So one thing that you should must consider is that momentum is a vector quantity, because velocity is a vector quantity. So force is also a vector quantity. V represents a vector quantity by this. We will discuss this in future class, higher classes basically. So from lesson 1 we have V is equal to U plus AT. If you remember this, we are doing nothing but I want to do actually, no, F is equal to M into A, and this is equal to M into V minus U by T. I can just simply, cancel it, and I have got this. And here I have, so from this you can also, derives that force is equal to MA. I have just proved here if these two statements are right or not. But we know now that what is acceleration. We know that change in the velocity. What is acceleration? It's the rate of change of velocity with respect to time. It's acceleration, right? So now we can say that force is m into a, and here we have proved, the formula of force, and it is directly proportional to mass and acceleration. So if you increase mass, force will increase. If you increase acceleration, force will increase. So we can also derive SI unit. That's how we have derived. So what is 1 Newton? It is the force. It's an actually important question. So force required to produce 1 meter per second square acceleration in a body of mass 1 kg is 1 Newton. So if there is a body of mass 1 kg, and to produce 1 meter per second square acceleration, we need a force, because to generate or to produce motion we need force. So the amount of force that is needed to create 1 meter per second square acceleration in a body of mass 1 kg is nothing but 1 Newton. That's what I want to say. And here we can, you can understand how motion and force is connected to each other, and it's very important. So we can say that force causes acceleration and momentum connects force and motion. Important. So example, in daily life, it is easier to push a bicycle than a truck because of mass, because the one with the smaller mass will require small amount of force, and it is harder to a harder kicks make the ball go faster because force is directly proportional to acceleration. Catching a fast ball hurts more because force is directly proportional to acceleration. So, what is Newton's third law of motion? Let's discuss it. And it's one of the most famous and widely used statement. It's for every action there is equal and opposite reaction. So whenever one object applies its force on another, the second object applies a force back. That means the both forces are the both forces are equal in magnitude, opposite in direction, and they are acting at the same time, but they don't cancel each other because action and reaction force acts on a different object. It's very important. So, for example, walking. So when we walk, our foot pushes ground backward. It is the action, and the ground pushes the foot forward. It is the reaction. So in this case, the forces are applied by two different objects. So the action is on the ground and the reaction is on the foot. That's why they are not canceling each other. Swimming, the hands push water backward and the water pushes the swimmer forward. Okay, the recoil of gun. So gun pushes the bullet forward and the bullet pushes the gun backward. Rocket motion, gas pushes downward and rocket moves upward. Well, third law explains why momentum is conserved and why motion is possible without support. So without reaction force, motion cannot occur. So so the conclusion from the chapter is force works in pair always. Action and reaction act on the different bodies and equal magnet they are equal in magnitude and opposite in direction. And the third law is very important, and the most important statement is that they don't cancel each other. Action and reaction act on a different object. I have already explained examples of walking, swimming, recoil of gun, rocket motion, and one of the important points is that the momentum is conserved. This is important, and we will see its derivation in the next video. Thank you, and thank you for watching this video. Don't forget to subscribe, comment, and share for the amazing content and easy to understand notes, explanations for CBSE class 9th and 10th.